Question number 8. It says so. Complete the following theorems. The angle in the semicircle is equal to 90 degrees. That's not difficult. The opposite angle of a cyclic quadrilateral is the opposite angle of a cyclic quadrilateral is equal to the this one is kind of awkward because it's like they want us to refer to the theorem that states that opposite angles of a cyclic quadrilateral are supplementary. The opposite angle of a cyclic quadrilateral, okay, is supplementary. Let's just say supplementary is supplementary to its opposite. The opposite angle of a cyclic quadrilateral is supplementary. Hey, I'll just leave supplementary for now. Yeah, when I say it's supplementary, it just means that its opposite counterpart will make sure that they both add up to 180 degrees. So let's not overthink it. It says O is the center of the circle in the diagram. Okay. And then it says here, BP is produced to M such that OM is perpendicular to AB. We have a 90-degree angle there. Okay, perfect. So with this 90-degree angle, what do we now know? It says here, AP intersects OM at L. Where's AP? AP, there is AP here, right? It intersects OM at L, yes. And then it says the following. It says BS is a tangent, B going all the way to S. This is a tangent, right? So if this is 35, it means that this angle here is also equal to 35 because of the Tangent-Chord theorem. Now, the other idea is this is a radius, right? And this is a tangent. So it means that this is automatically equal to 90 degrees. So if this is 90 and O1 is equal to 90, because they gave it to us as a 90-degree angle. They said they said AB is perpendicular to OM. So if this is 90 and this is 90, it means that we're dealing with lines that are parallel here. So all these conclusions here, you need to keep in mind that they're going to help you as you will be working out questions that they can ask. So they say this is 35. Fine. So they say calculate with reasons the size of A1. So A1 is this small angle over there. Oh, no. I made a mistake. No, man. A1 is the one that's 35 because of the Tangent-Chord theorem. Excuse me. I'd made a big boo-boo. So the reason why it's only A1 is because the triangle that is inside the circle is this one only. So yeah, but I did is. Anyways, yeah, so this angle here is the one that is equal to that one because of the Tangent-Chord theorem. I didn't even see this was out, but we're here now. So this is equal to 35. The reason for that, you're just going to say Tangent-Chord theorem. You see, Tangent-Chord theorem. Tangent-Chord theorem. So with the Tangent-Chord theorem, we have just got A1. So the next one here is O3, right? So O3 is, let's see what O3 is. O3 is this line, is this angle over here. Now remember, this one is going to be double the 35 because the angle at the center is double the angle at the circumference if they're subtended by the same chord. You see? So here we have this same chord here. So this same chord is subtending A1. So that's why this is 70. So we're just going to tell them that this is equal to O3. Yeah. O3 is equal to double A1. A1, which is going to make it 70 degrees. The reason is angle at center of circle. See? So, all that being said, we can move on nicely because it wants us to get P3. So any shape that has actual dimensions given should always be easy. P3 is also going to be easy because you see here you're working with red eye. I mean, lines that are equal to each other. So if this is 70, this is going to be 180 minus 70 divided by 2 because they are equal to each other. You see? Angles opposite equal sides. But let's tell them that OP is equal to OB, red eye. I mean, that's blunt, right? OP is equal to O what? OB, right? The reason is red eye. So that now we can say P3, therefore P3, right, is going to be equal to OBP. 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 The reason is angles opposite equal sides, like that. It's just angles opposite equal sides. So now that we have stated that those two angles are equal to each other, we can easily say, therefore, P3 is equal to 180 minus that 70-degree angle. Whatever is left, you cut it in half. And then the reason for doing this is interior angles of a triangle. So you see here, this is going to be 110 divided by 2, which is like 55 degrees. That's P3. And all this information is very needful because actually you could have also just said, what you call this is 55 because that would have been another route where you say this is tangent perpendicular radius, you say this is 90, you remove the 35 from 90, and then you'll be good. Let's see what's the next thing. They want us to get M1. Yeah, these are obviously the easier questions, asking us to get M1 here. M1 is not difficult because you see here, we know that O1 is equal to 90 degrees. It means the other side is also equal to 90 degrees. So if the other side is a 90-degree angle, let me just do this. This angle here is also a 90-degree angle, right? So this triangle here that we see is a right angle triangle. And this right angle triangle, that's where M1 is, you see. There's 55, there's 90 here, the whole thing, right? So you can easily get M1. So let's tell them that BOM is equal to 90 degrees. BOM is equal to 90 degrees. The reason is angles on a straight line. Angles on a straight line. And then now we can easily then say M1, more of a conclusion also, therefore M1 is equal to 180 minus the 90-degree angle minus the 55. Whatever is going to be left here is, I think, 35. Is it 35? Coincidentally, 35. What do you mean by 35, bro? Come on, it's not 35. Can't be 35. Oh, it is actually. Yeah. Oh, alternating angles also. But yeah, whichever way, everything is just linking up, but it's okay. So this is going to be 35. The reason for writing all this was interior angles of a triangle. But everything we stated in the beginning, you see, everything links up. It has to link up. So anyways, the next question, they're asking us to prove that OLPD, where is OLPD? LAPD. OLP, where is D now? I think they meant B. Because there's no D there. OLPB. Let me check again. Is there D? Let's see. There's A, B. There's not even a C, bruh. Yeah, I think they meant OLPB because there's no D in this question. So if you're gonna prove that this shape here is a cyclic quadrilateral, this one, this shape, this one is the one that you have to prove is a cyclic quadrilateral. This one. Now you can do that by showing that an exterior angle of a cyclic. No. Easiest one is the what you may call opposite angles of a cyclic quadrilateral supplementary. You see, and you can use angle P2 and P3. You see, this is a 90-degree angle. So this is 90 and this is 90. So they're supplementary. So you have a cyclic quadrilateral. So let's tell them that we know that BPA is 90 because it's an angle in a semicircle because it's subtended by the diameter of a circle there. So let's tell them BPA, 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 it's got 90 degrees. The reason there is angle in semicircle, angle in semicircle. There we go. And then now we can say BPA plus what? What's that angle there? BPA plus BOM. That's BOM, right? BOM. If you add this up, they should give you 180 degrees. You see, so here you can say therefore OLPB is a cyclic quad because opposite angles are supplementary. Okay, and then now we can do the next one. They want us to prove that BS is parallel to OM. You see, very simple. Now it's a 2-mark question only. So we already stated that this is 35 and we know this is 35. So we can just use that. You see, SBM is equal to M1. No, we can just say SBM is equal to 35. That's a given. M1 is equal to 35. That's proven. So because they are both equal to 35, we can say therefore BS is BS. BS is parallel to OM. The reason is alternating angles are equal. See, alternating angles. You know, angles. Come on, angles. Want angles? Alternating angles are equal. Okay, so they C now. C says we should prove that. Well, it's still in the name of proving that. We should prove that OP is a tangent to the circle L. We should prove that OP is a tangent to the circle through PLM. Where is PLM? There is PL and M. We should show that OP is a tangent. So the line we should show as a tangent is this line over here. I don't know which color to use because everything now is just like a rainbow, man. It's just like a rainbow. So we should prove that OP is a tangent to a circle that passes through these points here. You see PLM. Now the idea with what we have here is the fact that this is a tangent. You see. Now this tangent here, if this was a tangent, then it means that this angle would be equal to that one. You see. So we might as well use the colors that we were using for the 35 originally, because that's where all this is going, you know. Can I just have to prove that this is equal to this angle? Because if we do that, we'll be fine because of the Tangent-Chord theorem. So proving that that angle is equal to 35 is easy because you see the whole thing there is 90. It's already been proven. We know it. This is 55. It's also been proven. So we can just restate those statements. You see, P3 is equal to 90. Is it P3? I feel like I'm messing up. No, it's BPA. The angle BPA. Yeah. BPA is equal to 90 degrees. This has been proven already. And we want to tell them that this angle here is 55. P3 is what I should have just carried on, but anyways, we're gonna rewrite it here. P3 is equal to 55. This has also been proven. And then as a conclusion, right, we can now state that the angle P2, you see, therefore P2, it's more of a conclusion. Therefore P2 is gonna be equal to 90 minus 30, minus 55, gonna be left with 35. So because you've shown that this angle definitely is a 35 also, you're good to go because you are showing that this angle at the tangent is equal to the angle here, which is subtended by this chord, right, of our circle that would have gone around there. So in this kind of a situation, you can then just say, therefore, this will be a tangent to the circle. So you can say, therefore, OP is a tangent to the circle through P, L, and M because of the converse of the Tangent-Chord theorem. Because of the converse of the Tangent-Chord theorem. Yeah, but we love to see it. Let's move on to question number 9.